I'm Saskia. I'm from Ben-Gurion. And I want to start with one of the biggest clashes we have in theoretical physics. So when you just look at your phone, something that you use every day is GPS. Why is it working so well? Well, because we understand the theory of general relativity very well. Also, when you look again at your phone, like the promise for like the next capabilities come from quantum computations, and that again comes from us understanding the quantum world, quantum field theory, quantum mechanics, etc. When we physicists, we work with these theories, we have different mathematical formulations for them. So when we work with general relativity, it's differential geometry, so it's like something smooth, something malleable. It's like clay. You can think about it as clay. And quantum field theory and quantum mechanics, you can think it's group theory, roughly, and you can think of small Lego blocks that we put together. Now, just imagine you have a child, and you give it, at the same time, clay and Lego blocks. What's going to happen? Yes, a catastrophe. Well, this is exactly the same that is going to happen when you try to unite these two theories together. They just clash. They don't work together. So what does that mean? Well, that means that you need to change your paradigm. That means that some of your assumptions were not the right ones. So there is, for the moment, like a big popular theory, which is string theory, which is the idea that actually all these different theories that are different patchwork of the world we actually see are very small vibrating strings, different vibrations or different aspects of the world we see. And, well, that's fantastic. We have managed to unite all the forces of nature and all the particles. Well, string theory comes with a lot of challenges. And one of its challenges is that it has to live in more dimensions that we can actually see. So, okay, what do I mean by that? So let's go basic. What do I mean with a dimension? So, well, you're familiar with the world we move in. So you know that we have actually three spatial dimensions. We have forward, backwards, up, down, left, right, probably the opposite. And since we are generous, we're also going to count time as a dimension. So we have 4 space-time dimensions. Now, when you study string theory and you look at the equations, well, the equations at some point, they're telling you that strings need to live in at least 10 dimensions. So what do I mean? Because that means that 6 of them, we just don't see them. So they need to be hidden. So how are they hidden? Well, I made a table for you there, and you have this line, this very thin line there. And now just imagine you have a microscope in your possession that is not a microscope of today. It's also not the one of the foreseeable future. It has such a resolving power that you resolve, and you see that, no, it's not a line, actually. It's a pencil that has this extended dimension that's curled up. So this idea that these dimensions that you couldn't see are curled up, they are hidden from your view, because we don't have the resolving power now to see that. But they are there. So, okay, so that just means that we have 6 crayon shapes, hidden dimensions in our world. Well, no, it's a bit more complicated than that. We actually have many possibilities to hide these hidden dimensions from our views. And not all these dimensions are actually compatible with quantum gravity, so uniting quantum mechanics and the theory of gravity. And that is one of the biggest challenges in my field today. So now I want you to pin a pin on that. Remember that there are so many possibilities. I'm going to return to that. And my job, essentially, is to understand this question, but for that I use a tool. And this tool is something that is known as a duality. So, well, actually as a child, I didn't know it, but I actually already quite like this idea of this concept of duality. There was this story, well, it's still there, of Stevenson, the strange case of Dr. Jekyll and Mr. Hyde. And it's about this very good citizen, Dr. Jekyll, and he managed to concoct a potion that turns him into an entirely different person, this Mr. Hyde, that's capable of mischief and crime. But the point of the story is that they're basically the same person. So there are 2 sides of the same coin. There are 2 different perspectives of something that's equivalent. It's a duality. And this idea is something that we use all the time in mathematics and physics. And that I'm using in string theory. And let me tell you how I'm using it. So I told you to put a pin on the fact that we had all these shapes on which we can hide our dimensions. Well, at this stage you could have told me, well, Saskia, your job is so clear. You just need to go very methodically, one after all possibilities, and at the end of the day, you will find which is the right one. Well, I have 2 complaints. The first one, there are like 10 to the 5 runs of them, which is basically infinity. So going one by one, would be a total nightmare. Second point is that when I'm checking one of these shapes, it takes me several months. So there is no way I'm doing this. So my strategy is different. I use a tool, and I'm looking at subsets. So this tool is exactly what I told you. It's a specific type of duality, which is called T-duality. And this T-duality takes shapes, and it essentially produces mirror images of it, such that I can go very efficiently from one shape to the other, and I can also discover new shapes which are very interesting. Because that's what also I'm doing. I don't care about this whole landscape of I don't know how many shapes. I'm interested in a very specific and very interesting subset of these shapes. Let me present them to you. So we call them non-geometric, but really you can think them like as chimera shapes. Because like for chimeras, when we are essentially gluing parts of animals together on the same body, these are shapes, geometries, that we glue together in things that we don't expect to make sense. But the point is that they are there. They are generated by T-duality. We need to understand them. But the challenge is that, well, they are mathematically very difficult to handle because they are very different from what we're used to. And it is precisely what I'm doing. I'm using this technique of T-duality and its mathematical formulation to understand these shapes on a mathematical level and understand whether actually in string theory we can hide these dimensions using these shapes. So I took you to a long journey with lots of exciting questions. So it started with really the basic question of to acknowledge that we have this very big clash in physics and we would like to have just one unifying theory. And to do so, we maybe need to accept that everything is a tiny vibrating string. But if you accept that, we have to hide dimensions that we don't see. So where are they hidden? How are they hidden? And I'm studying whether they are hidden on these specific chimera shapes. And many, many questions are still to be left to understood. And it's with this question that I want to leave you today. Thank you, Idiot, for the attention.